Hello, this is a demonstration of a controller board that I created to go along with the functional test software that I had created, and I've already released the software in this same version. Um, I'll give the schematic to the board of this board at the end of this. I want to make sure everything's correct so that there's no mistakes if you try to build it. What I would recommend, you build it to prove that it works, and then you go and do a schematic capture and you build a small board that has everything on it. You don't have to worry about it. Have a bunch of wires. But anyway, so to start out, what I'll do is I'll show you how I'm doing this. One, I have a test that I'm calling. I'm just calling this same test over and over again. All it's doing is that, and it's just an audio thing. Inside of here, it's really not doing much. You can see what it's doing. It's just, pass fail results coming out of this thing. But then over here, I also have, you know, my controllers. This is what I'm using for my controller files. So basically, this is stuff I downloaded. This is what I have to use to control the. This is the FT232H from Adafruit. Basically, it's a USB interface to the computer, which breaks out the bits that I need to control the hardware on this board. And I'm controlling the hardware by telling what value I want here. Right here, I'm setting the bit 0 is true. So that'd be test 1. Test 2, it goes to the next bit. So it's this one is true. Test 3 sets 2 bits is true right here. Because what I'm doing, I'm using the first I'm using bit 0, 1, and 2 to control this part of the hardware. The other bits goes directly to here. So that's what you'll see in the next one. So bit 4, this will be test 4. That one is, goes to this bit here. And then test 5, instead of being a 101, it goes down one down here because it's not going into this. It's just passing straight through. And the same with this one right here. It passes straight through and it goes to the output over here. And I'm going to show you how it works. I'm going to prove that it works, and how I've set it up with this software. So first, I want you to notice that there's no test results over here. That's so I'm just going to go ahead and I'll show you. Um, this is the test that I created for this board. I'll go ahead and edit it so you can see what I used. The first one I used, it has test dialog and no user response. You can see there's no user response, but there has dialogue right here. The dialogue, I just added some things here, and then I changed, which test is running. Then I selected the test, and then the rest of them that I added was add a test with no dialogue and no user response, and you can see that. So there's no dialogue, and all you have to do is you select, what you want for your test, and it's the same for each of these. So that was test 2. You just keep going through. You can see that I selected all of these. So I just added all these as a test, and you can see it over here. And then at the very end of it, I set everything back to 0. So at the beginning, I set everything to 0, and at the end, I set everything to 0. I'll go ahead, and I made this as my default project already. So I'll go ahead and go back to the functional test. I'll plug this in, and I'm going to show you a demonstration, so that you can see that this works. I will also give you the schematic, for this board at the end of this. I've already released this software, and I'm giving you the software with the source code, the source code, so you can compile it yourself. So plug the USB in. This is only 5 volts. And again, I'm going to make sure that the schematic is correct for this board so that you can create it yourself if you want to. I'm going to hold the board up like this, and I'm going to go ahead and run the test and show you that it works. So first, I'll just give it a serial number. We'll call it 00071. How's that? And I'll press start. And this is where it has the dialogue. So it says attach test cable to, I just added some stuff in here. Then you press continue, and it should just run right through the test. And you'll see the LEDs are moving as it's changing through the test. Goes, so that would be the first one. Now you see I have a file over here that just loaded 647, the 648 down here. So it just created that file. Now let's say I want to run the test again. Maybe the board is a AZ serial number. Maybe that's a serial number this time. So just run it again. Press continue. Okay, so that this is just to prove that the concept works, and that's the whole intent of this. Um, the my idea of how this would where this board would work, it would be controlling, an output maybe where you make a connection so you can measure voltage at the end. If you wanted to measure a voltage, this was basically designed in thought of to a test setup I saw at ACOS Incorporated where they were using multiple ohm meters to or voltmeters to measure a voltage. This would make where you just use one voltmeter and you can read the measurements back to the computer from the voltmeter. And this is the schematic for the little board that I created here for the digital selector circuit. And first I did it in LabVIEW and I proved that it worked. And then I designed the board and laid it out and connected everything together. This is the breakout board. This is the USB interface from the computer to this board. So that and I got these are the bits that I'm using, C0 through C7, and I'm using the ground pin. I'm not using any of these other pins. Do not use the 5 volt and the 3 volt to supply power to this board. Do not supply power to this board. That is done by the USB interface, by this connection right here. Adafruit gives a warning about using that 5 volt and that 3 volt. It gives you a warning about using that. I would not use those. This is the interconnect for the chips themselves, the OR gates. There's 3 OR gate packages. There's 2 inverter packages and 1 AND gate package that I'm using. These are quad OR gates and quad AND gates, meaning there's 4 OR gates in each package, 4 AND gates. And this has 6 inverters in each of these. That's the pin outs that I used. If you look at this is how I'm connecting the power supplies. The warning is I'm using a 5 volt power adapter, a fuse holder with a 1 amp fuse inside. The power adapter is 2.5 amps. It's a 1 amp fuse holder. And I know it is 5 volt DC that I'm using for this. The Adafruit board does not. I'm not supplying power to this. I'm only connecting the ground together from this board to the Adafruit board. Just the ground pin. That's it. And 5 volts is being supplied from a power adapter. This power adapter to these other pins on the OR gates. The Adafruit, the only pin. This is just the ground pin that I'm using. This one right here. I'm not using anything over here, and I'm using C0 through C7 here for the inputs for right here. The GPIO C2, GPIO C1, GPIO C0 goes to these bits right here. It has the input values right here for the pin outs, and then it has the outputs right here. I'm using 1.5 k ohm resistors for the outputs with the LED connected to ground so that I can see what's happening. My intent was to have this switching through maybe a relay or something so I can select which output I want to measure. I have it where I can measure multiple outputs at the same time. This output down here, output bit 0, This is where I can select this bit if everything's low. Everything's low. If it's high, then it goes to bit one, bit two, bit three, bit four. This is the none. Nothing selected. None of these are selected. That's what this one is. Um, I go down to this one. This gives you the pin numbers. Pin numbers right here. So the next one would be the final bits that I have, which is GPLC3 and GPLC4. That's for the fifth bit and the sixth bit connections. They don't go through any circuitry up here. They just go straight through. And that's basically the pinout in the schematic of this board, so you can build it if you want to. But I warn you to use a fuse, and you use a fuse that's smaller than what your power supply supplies. That's something someone had warned me about before. This is the website for the Adafruit board that I am using for the USB interface. All you have to do is go to adafruit.com, and here you can type FT232H. If you press return, it'll come. This is the board I'm using. It's a FT232H breakout board. When I go to the learn, you can order it here for $14.95. You can order on Amazon as well, but you might as well order it from here. It's probably cheaper if you do this. If you go to learn and you type the same thing in here, then it comes up with this little area which it tells you how to set everything up. So you have an overview, you have the assembly and wiring. It talks about how it works, the serial UART, stuff like that. And then you go into the setup area. This tells you what you have to download to make this work, what libraries you need. I'm not using CircuitPython or the CircuitPython libraries. I'm using what they call Blinka. You can use Blinka instead, and you don't have to have all this other stuff. If you keep going down, it'll tell you, what you have to just keep going down and selecting. So now I'm in this area. The next area will be set up. So I'm not using this part of it. It just describes what it is and how to use it. Now it goes to the setup page. You have to download this. You have to install this. You have to have Python 3.0, and then you have to install these files right here. This is what makes it where you can use this board with your computer. Python 3, it talks about Python 3 is the Zadig driver. The Zadig software, you can download this from their website, and it tells you exactly how, what you have to do to set it up to where it works with your computer. You'll be able to look at your device manager. It tells you how to do all the commands here from the command prompt, so you can download everything you need to use. There's an important step down here that I wanted to mention, as with Blinka, because this is what I'm using, Blinka. You have to do this. You can set it. It says you can set it, permanently in the Windows environment if you want to, but I'm not. I'm just setting it every time I call the scripts. But that's very important. This has to be set, or this board will not communicate with your computer. You have to run that command every time. For the pinouts of this board, I'm going to show you this part of it because I want you to be able to understand. And I'll mention it also has post-install checks, so you can make sure everything's working. But the pinout is right here. I'm using this version of it. These are the GPIOs that I'm using, 0 through 7, C0 through C7. I'm connected to, my board is connected to C0, C1, C2 for one part, and I'm going to show you the schematic in a minute. And then C3 and C4 are connected to the other ports, the extra ports that I have. And that's about everything I can show you for this board. It's very important that you know all that before you set it up if you're going to use this. Another very important thing, do not use the 3.3 in the 5 volt. Do not use these to supply power to this board. It says if you try to use more than 500 milliamps, it might damage this board or it might damage your computer interface. So I would not use these. I use the ground, and I'm using the GPIOs, and that's all that I'm doing with this board.